Okay, in this tutorial, still in 5.4, but we're going to be looking at division of radicals. Uh, okay, so we've got a few different examples and different types of examples with divisions. And a couple of rules follow from division. You can't leave radicals in a denominator in any case. And also you have to be careful that if you have a radicand, that means something that is under the radical sign is a fraction. You can't have that either. So keep that in mind when you're doing division. So the first one is a simple example. If you have a radical on top and a radical on the bottom, and the bottom one is a multiple of the top one, you can do simply like this. This would be the same as 2 root 10 over 5, because that's a perfect multiple. 10 is a multiple of 5. So this would be the same as 2 times root 2. And that would be how you do those. However, this one here doesn't work quite so simply. So you have to do something called rationalizing. So that what you do there is you multiply by root 30 over root 30. And as you may have noticed in the past, if you're multiplying a root 30 by a root 30, that's just going to become out to be the number 30, okay, for square roots. Okay, so that's going to equal 2, and under the root sign here we have 3 times root 30, or sorry, 3 times 30 under the root sign, and this is just going to be 30 here. That's, if you want to work it out, you could. That'd be 900, the square root of 900, 30. So in our case here, we have 2 root 90 over 30. Now, root 90 can be reduced. 2 times 9 times 10 over here, over 30. So this is going to be like 2 times 3 root 10. Over 30. So this is the same as 6 root 10 over 30. And we can reduce by taking out 3 from the top and bottom. So that would be 2 root 10 over 10. Oh, I can even take out a 2 there. I guess 6 goes into 30 perfectly. So this would be the same as root 10 over 5. Or 1 root 10 over 5 if you like. Okay, so that's an example of some multiplying there. The next one here is a little more complex, but we still have to rationalize by multiplying by root 3 over root 3. You could multiply by 2 root 3 over root 3, but you don't have to in this case. You just have to worry about the radical sign. So multiply like we did root 30 over root 30. In this case, we're going to multiply by root 3 over root 3. But remembering that this is in brackets. So this is going to give us 4 times, under the radical sign be 9, so that would be 3. Remember, root 3 times root 3 is just a 3. And that's our first term, and then we have to multiply out our second term on the top. That would be 3 root 6. Okay, and the bottom is going to just be 2 times the root of 9, which is 2 times 3. And that's going to get rid of that radical on the bottom for us. So this works out to be 12 plus 3 root 6 over 6. Which now we can reduce, take out partly. 12 divided by 6 is going to be 2. Well, I guess we can't take out a complete 6 because you can't get 6 out of 3. You can only take out 3. So take out a common factor of 3 there. So 3, that would be 4 plus root 6 over 2. Or if you like, you could say 2 plus root 6 over 2. You want to write it that way as well. There's more than one way to write these radicals. Running out of pen power again. Okay, so I'm just going to check the field of view, make sure that one was in there for you. Okay. That's 3 examples of division, but we want to do one more example that has to use conjugate forms. If you have 2 radicals on the bottom, you have to use the conjugate form of the radical to get rid of it. And the conjugate form of the radical is just the same binomial with the opposite sign in it. And then you have to multiply both the top and bottom by that. So this would be 12, the root of 12 minus the root of 8 here. And this would be the same here on the bottom. And this is called using conjugate forms to simplify. And then you have to multiply that out. So in our case, we're going to do that. So it's going to be 2 times the root of, well, 3 times 12 is actually 36. Okay, and we have to do FOIL method, so we still have minus the root of 24, and then we have to go to the 8 part now with this part. So this would be 2 plus 2 root 24. And finally, in the last one, we'd have plus, because they're both minus signs, the root of 16. And that's the top. The bottom is just going to be, well, because they're opposites, you don't have any middle terms, so it's just going to be 12 minus 8. That's what the conjugate is useful for. It helps you reduce it down. So this is going to be 2 times 6 minus, or positive, sorry, plus the root of 24 plus 4 over 4. So this is going to give us 12 plus 4 root 24, plus the root of 24. Don't want to make a mistake there. Over 4. So this is going to be 16 plus the root of 24 over 4. So we can reduce the root of 24 if possible. Look for a perfect square. And in fact, 4 will go into that. So let's do that. 16 plus 4 times 3. Oh, sorry, 4 times 3. 4 times 6 is 24 over 4. So this would then give us 16 plus 2 root 6 over 4. We can take out a common factor of 2 there, so we have 8 plus root 6 over 2. And that's our answer, simplified answer. Make sure that's in the field of view. And that's examples for division. In our next tutorials, we'll be moving on into looking at the solving of quadratic equations.